This route of these videos doesn't super relate to what I'll prove about periodic points along the other path. But this video is an excuse for me to talk about some things that are just, I think, are really cool, and they inspire some curiosity and motivation for studying fixed point theory for those that like more applications of things. So in this video, I'm going to go through two different applications of Brouwer's fixed point theorem. The important thing to note here as I get started is that you might be really unsatisfied by the end of this video because Brouwer's fixed point theorem is a non-constructive theorem. So what I mean by that is that it's an existence theorem. It doesn't actually tell you where or how to get the fixed point. That being said, here is the statement of Brouwer's fixed point theorem. So Brouwer's fixed point theorem states that if you use a continuous map from a topological n-ball into itself, there has to be a fixed point. So just jumping right into the applications of this. We all have seen a topological n-ball. A piece of paper will do. At least in the two-dimensional case, this works. So I'm gonna go do some things with a piece of paper. The continuous map that we're going to use here is extremely fun and cathartic. Yeah, just crumpling the paper works. Now, if we take an identical piece of paper and place the crumpled one somewhere on top of it, we can restate the theorem as it applies to this scenario. That is, there exists a point in the crumpled piece of paper that has only moved vertically from its corresponding point on the flat piece of paper. Now, just to more fully explain what's happening here, in order to go from the piece of paper to itself, we have to add in a map that we can't do with the crumpled piece of paper, and that's projecting it back down onto the piece of flat paper. Now, doing that only changes the vertical position of the points in the piece of paper. So we're still doing a continuous action. The other version of this that is commonly used to demonstrate or sort of give an example of applying Brouwer's fixed point theorem in an everyday life sort of way that is still not super useful, but just boggles the mind a little bit, is applying it to a storm in a cup. So to go ahead and show this, what we do is we take a glass of water and let it rest. And then once it's done resting, we go ahead and stir the water and let it settle down again. Stating Brouwer's fixed point theorem in this scenario tells us that once the water has settled down after being swirled, that a point in the fluid has returned to its original position prior to being swirled, which also feels like it shouldn't be real and that it shouldn't happen, but it does. And you can prove Brouwer's fixed point theorem. It takes a little bit of work, which is why I did not decide to go about doing so in these videos. The other cool thing here too is that if you try to force that point that stayed the same into another position, you would also force some other point that had been previously displaced back into its original position before being swirled twice. Anyway, that's all I really got for you in this video. Let me talk about two things that are just really counterintuitive and make me very happy about the universe and what happens in the universe. So there's that. But if you want to learn more things about Brouwer's fixed point theorem, you can actually check out this other video that I did on Sperner's lemma, which is the combinatorial analog of Brouwer's fixed point theorem. And you can actually show in its most general case that it's equivalent to Brouwer's fixed point theorem. I'll put that over here. It's about how you can cut a square into triangles. Also, if you want to go the other route and learn about Sharkovsky's theorem in the case of n equals 3 and start developing that knowledge, you can go over here. And you can subscribe for more mathematics videos by clicking the center here. As always, I'm Nathan, this is Chalk, and I will see you next time. This route of these videos doesn't super relate at all to what I'll prove about periodic points in the other route, but this is my excuse to talk about the camera is gonna die. Okay, fine, come at me, camera battery. Okay.